Good morning everyone. Today's lecture we are going to talk about various types of dryers for food process engineering. So, this lecture and the previous lectures talks about the major processing equipment in food process industry. So, one is dryers, the second one is the heat exchangers. So, you also might have seen in many of the lectures we were talking about mainly in the continuous flow process heat exchanger, plate type heat exchanger, and also we have seen design procedures as well. So, these two lectures are about that. So, what are all various types of dryers used in food processing industry as well as the heat exchanging equipments used which is nothing but a heat exchangers which are used in food industries. Before going into various type of dryers, we also going to see about the very basic mechanism of drying and how to calculate the drying time. Then after that we discuss 3 to 4 types of various dryers used in the food industries. So, the first, the process of drying. What does it mean by drying? It is also called as dehydration. So, which is defined as the application of heat under controlled conditions to remove the majority of the water normally present in a food by evaporation. So, drying means the application of heat under controlled conditions to remove the majority of the water. So, this is very much important, normally present in the food by evaporation. So, this is done at using heat. So, if we use the freezing phenomena, so that is also called freeze drying. So, there the mechanism is sublimation. By sublimation we do freeze drying, but here by evaporation the majority of the water is removed because we are concerned about the thermal processing. So, by applying heat, how to evaporate the water from the surface of the food particle. The main purpose of dehydration or drying is to extend the shelf life of the foods by reduction in water activity. So, we are doing here the water activity reduction, and it inhibits microbial growth and enzyme activity, but the processing temperature, right, whatever the heat we apply, the temperature, processing temperature is usually insufficient to cause their inactivation. So, this is another important thing to remember. By drying, we are just reducing the microbial growth or enzyme activity, but we are not killing any microorganism because the processing temperature which is applied in the drying is not sufficient enough to inactivate the microorganisms. And any increase in moisture content during storage, for example due to faulty packaging, will result in rapid spoilage. So, the drying here, the main aim is to remove the moisture content to reduce or to inhibit the microbial growth or enzyme activity, but since it is not inactivating, so there is a possibility for recontamination. So, for example, after the storage, after the drying, if the product is being stored in a storage unit, so that time if it grabs the moisture content, then the food may get spoil, right. So, it cannot guarantee the spoilage during storage, it is just that it removes the water, by that way it inhibits the microbial growth and enzyme activity, but after drying, so we need to take care of the further decontamination level. The reduction in weight and bulk of food reduces transport and storage costs. So, that means, so if we remove the majority of water, right, and that reduces the weight of the product and also the bulk of food in the sense it adds, because water density is 1000 kg per meter cube. So, it adds weight, right. So, that is reduced and it will be very easy for us to transport and storage, and provides convenient product for the consumer or more easily handled ingredients for food processes. Obviously, if we remove the water content, the water activity of the food product is reduced. So, in that way it is convenient product for the consumer, and also for the food processors it is very easily handleable because the lot of weight of the product is reduced. It causes the deterioration of both the eating quality and the nutritional value of the food, right. Since we are applying the thermal process which is done by hot air, at particular temperature, it also or it may cause deterioration for the eating quality and the nutritional value. Dryers aim to minimize these changes by selection of appropriate drying conditions for individual food. Right. So, this is in my hand, right. If you remember our earlier classes, we also talk about the time temperature combination. Right. The one of the major disadvantage in the thermal processing is nothing but the temperature, high temperature, due to which the nutritional value of the food gets deteriorated, and sometimes it gives the overcooking that is not appealing for the consumers to consume the food, right. So, this temperature combination, time temperature combination I can play with. So, that is the way we told the low temperature high time process and high temperature short time process. So, all the processes we have discussed to how to play with time temperature combination to get or to regain the eating quality and nutritional value. The same thing is applicable here, because by the way I can take care of my drying conditions for individual foods, I can give better eating quality and nutritional value for the food. So, the examples for dried foods are coffee, milk, raisins and other fruits. This is very much famous, dry fruits, and pasta, flours. This flours includes the bakery mixes, beans, pulses, nuts, breakfast cereals, tea and spices, and egg powder, flavorings and colorings, lactose, sucrose or fructose powder, enzymes and yeast. So, everything comes as a dried powder with reduced water activity, not to contaminate further. So, then we told about the basics of drying. In the drying, what are all the care should be given to get the better eating quality and not to degrade the nutritional value. And now we are going to see about the dryers, right, the equipment used and what are all the measures I need to care about while selecting the particular dryer. A dryer used for drying food should not be of such a nature that food is in danger of becoming unfit for human consumption after drying. So, this is also another thing. After drying, it should not have any contamination or it should not be unfit for human consumption, and the planning of a dehydration plant is just as important as the design of dryer. So, this design of dryer we have while discussing in the previous lectures itself, we told that there is something called GMP, the good manufacturing practices. So, any design of thermal equipment in the food processing should follow the good manufacturing practices. So, now it is told that it is not only the dryer and the dehydration plant itself, because if there is any previous contamination in the dehydration plant, so this also affects the drying operation. For example, we are just keeping the food inside the dryer and taking out after the drying operation. The environment of the dehydration plant is not contamination free, then it will be a dangerous for drying operations as well. So, a good dryer can be dangerous if planning is bad. So, that means the plant is also should be contamination free. Mechanization and automation have made great progress in the cleaning of dryer, both batch and continuous, previously cleaned manually. So, the cleaning operation, right, this we discussed in the pasteurizer itself. The cleaning is very much important, because we also told that each particle should be at the particular pasteurization temperature. If any food chunks by chance left in the pasteurizer, it will add as a seed for the contamination. Same thing here. Previously these dryers were cleaned by manually. Now we are applying the automatic control, that is nothing but a cleaning in place. So, when you do the automation in the cleaning process, we also need to be ensuring the cleaning is done properly, right. Earlier the machines were opened every day, and if certain parts were not especially hygienic, they were given extra cleaning. So, this is possible in the manual, right. So we know certain parts need extra cleaning. Earlier the machines were opened every day, and wherever the extra care or extra cleaning is needed, that was done manually. But in modern dryers we employ CIP with computer controls, but here also if there is any parts of the dryer needs extra cleaning, that can be done manually after the CIP with the computer control. To produce microbiologically safe dehydrated foods, a hygienically designed dryer is needed. So this is important, because all other industries, even chemical industries uses the dryers in very much frequent, or in every almost all industry uses the dryers. But there I need not take care of the hygienic part, because the production of chemicals, so maybe purity is needed, but we do not much bother about the hygienic conditions in the dryer. But in food process industries the same dryers were used, but the hygienic part I need to give extra care, because the food is going to be consumed after the drying process. The dryer itself can be a main source of bacterial contamination of foods if the design and fabrication do not conform to high levels of hygienic standard. So while designing and fabrication itself we need to take care, because the bacterial contamination wherever it occurs, we have seen in the pasteurization as well as sterilization itself, the holding tube, why it should be at some slope, and also we have seen the walls and places where the possibility of milk chunks to be stay, so that should be cleaned properly, right. Here also the bacterial contamination can occur in the dryer as well, wherever there is a room for crevices or dead areas, right. So they have to be taken care while designing itself. Design and fabrication should not leave such a crevices or dead areas for the bacterial contamination, because if food chunks go and stay there, then it adds up further bacterial contamination. Hygiene in the dryer is necessary to prevent food poisoning and to reduce the food spoilage. So hygiene part is very much important. A well designed dryer is accompanied by a sound instruction for its installation, operation, cleaning and maintenance. So this is to be designed while design and fabricate dryer itself. So to ensure that it can be freed from relevant microorganisms, the dryer must be properly cleaned before process begins. Where crevices or and dead areas cannot be avoided for functional reasons, equipment may have to be dismantled for cleaning, right. So we told while designing and fabricating dryer itself, we need to take care of these crevices or dead areas. But for functional reasons or functional flexibility of the dryer, if these have to be there in the design of dryer, then we need to ensure the equipment can be easily dismantled for any extra cleaning, because these areas need extra cleaning. If we are not able to provide that by CIP, at least we need to dismantle the unit for further cleaning by manual. Care must be taken to prevent the contamination of foods with rodenticide and pesticide residues. Sometimes whatever we use for the cleaning itself may stay in the dryer, so that adds a further contamination of the food, because that may be poisonous as well. So that also the care should be given there as well. Three basic factors that are important for hygienic dryer design are actual design, fabrication and finish. This we told. Here itself we can check whether any dead areas can be avoided, and materials of construction. So this is, we need to ensure this is a smooth surface, because any pits or crevices adds the further contamination. And cleaning system adapted for the maintenance of the dryer. Normally CIP is applied, so if needed there has to be a manual cleaning, and the design of dryer should give the room for manual cleaning, because it should be disassembled or dismantled for cleaning, and it is easy to dismantle for manual cleaning. So this also another basic factor. So the safe practices are also being ensured while designing a dryer. So one thing is the surfaces in contact with the food should be inert to the food under the conditions of use, and the constituents from their surface must not migrate into the food or be absorbed by the food in quantities which could endanger the health. So, this is the where your food materials are kept inside the dryer, where the place, for example, we have a tray, right. In that tray your food materials are kept. So, these surfaces should not react with the food material or any constituents from, for example, the food material, some component in the food material will react with the material used in the tray, right. So, if there is any reaction between the food and the surface where the food particles are kept for drying, there should not be any reaction, or there should not be any corrosion which further leaves the components transfer between the food material and the surface. All surfaces in contact with the food must be smooth, non-porous, because it should also avoid any pores in the surface of the tray where your food materials are kept, right. So, that particles of food, bacteria, insect eggs are not caught in microscopic surface crevices and become difficult to dislodge, thus become a potential source of contamination. So, one thing may be argued is, like, even though it is a porous or the surface is not smooth for functional reasons, then there may be a cleaning which takes care of removing the food chunks from the pores or the rough surface, right. But sometimes what may so happen is, in the pores the food materials gets lodged and it cannot be cleaned properly even if you apply manual cleaning. So, as far as possible, the surface where the food materials are kept should be very smooth and it should be non-porous. All surface in contact with the food can be readily disassembled for manual cleaning. In accordance with the current practice, CIP techniques are preferred with the computer control, but this is not practicable. The design must follow for the ready dismantling of the relevant parts of the dryer for manual cleaning. So, as we said here, if certain parts need manual cleaning, so we supposed to give extra care or extra cleaning certain parts, then the design of dryer should give the provision to dismantle or disassemble the dryer for extra cleaning. Dryer must be so designed as to protect the contents from the external contamination, including accidental ingress of foreign matter, for example, bolts, nuts, washers, gaskets. So, this also should be contamination free, because these are all the small components which are used in the dryers. It is not only the drying surface, the bolts, nuts, washers and gaskets are also should be contamination free. The exterior or non-product contact surface should be arranged so to prevent harboring of soils, bacteria or pests in and on the equipment itself, as well as in its contact with the other equipment, as far as possible with the floors, walls, hanging supports. So, this is where I told the dehydration plant itself. Okay. So, certain dryers, what we do is, we have a the conveying mechanism, right. So, with which the dryer trays were kept inside. Okay. So, this is the way we stack the trays inside the dryer, right. So, when these parts are coming from the outside to inside the dryer, so there may be a chance for contamination it brings, right. So, it is not only the particular dryer, the whole environment of the dehydration plant should be contamination free. Otherwise, when it is in contact with the outside surfaces, or when it is contact with the other equipment, for example, after drying it will go to storage and distribution, right. So, there also this line has to go to further storage and distribution unit. So, in between also there should not be any contamination. So, for the dryer where the food material comes from, and after drying where the food material goes, that also should be contamination free to ensure the hygienic in the dryer, right. So, we have seen 5 best safe practices. One is the surface where the food material is kept should not be reacting with the food material, and the surface should be smooth and non-porous, and when certain parts of the dryer needs extra manual cleaning for functional reasons, the CIP techniques or the design of dryer should ensure the dryer can be disassembled and dismantled very easily and further assembled and mantled without any difficulty. And also it is not only the drying surface, and also the bolts, nuts, washers, gaskets also should be contamination free, and not only the dryer, for the dryer where the materials comes from, and from the dryer where the material goes, that also should be soil free, bacteria free and pest free. In short, it should be contamination free. So, the general classification of dryers. So, based on particle, slurry, liquid suspension, the dryers can be chosen in the processing mode, whether we want batch or continuous mode, based on the mode of heat transfer, convection, conduction, electromagnetic radiation and combination of conduction, convection and electromagnetic radiation, based on the product temperature above freezing point or below freezing point. This comes in the freeze drying. Okay, we have seen this is a sublimation, and that above freezing point is nothing but the evaporation. And based on energy source, electricity, gas, solar, wind, biomass, based on mode of operation, cyclic, intermittent, continuous, and based on operating pressure, atmospheric, vacuum and high pressure. And before going into the main classification of dryers or the various dryers used in the industry, we also should know little bit about psychrometry. I am not going into detail, but because the drying conditions, right, in the first slide itself we have told the drying conditions used is very much important to maintain the nutritional value of the food as well as the food quality, right. So, for that the drying conditions to be chosen, the 3 parameters important for drying conditions is relative humidity of the air and temperature of the air as well as the velocity of the air. When we talk about relative humidity, so we also should know basics about air water vapor mixture and what is called moisture content, what is called relative humidity, dry bulb temperature, wet bulb temperature. So, we are going to spend very minimal time. So, if you have further interest, please refer any of the master answer book, and I also give the references at the end of the slide for further reading about the psychrometry. There are large number of factors that control the rate at which food dry. One is processing condition, nature of the food and dryer design, right. So, the nature of the food we are by now know, like low acid food, high acid food, and which type of thermal operations to be applied. So, based on nature of food we are okay with, but based on the processing condition, this is what we supposed to give certain attention. And based on the dryer design, because already designed and we are not going to discuss anything deep about dryer design except drying time, how to choose. There are 3 interrelated factors that control the capacity of air to remove moisture from a food. So, this is where I told. One is the amount of water vapor already carried by the air. So, this we can get to know from the relative humidity, and air temperature and amount of air that process over the food. So, we can call it as a mass flow rate, or if you fix the drying surface area, then it may be a velocity as well, right. So, the velocity and air temperature as well as the relative humidity. So, the moment I talk about the relative humidity, which is nothing but amount of water vapor in air expressed as either absolute humidity, which is termed as a moisture content, or relative humidity, which is measured in percentage. So, this will be given by kg upon kg, kg of water vapor per kg of air. And psychrometry is the study of interrelated properties of air, water, vapor system, and these properties are conveniently represented as a psychrometric chart. Okay. So, that we are going to see. This is the psychrometric chart. So, if you see here in x axis, what you see is a dry bulb temperature, right. So, what is dry bulb temperature? The temperature of the air measured by thermometer bulb is termed as the dry bulb temperature. So, what we normally measure at labs, so that is nothing but a dry bulb temperature, which is in degree centigrade, and in the slanting y axis it is given as a wet bulb temperature, right. So, what is wet bulb temperature? If the thermometer bulb is surrounded by a wet cloth, heat is removed by evaporation of water from the cloth and the temperature falls. So, this lower temperature is called wet bulb temperature. Here in the thermometer we wind the wet cloth in the thermometer bulb. So, the heat is used to remove the water from the wet cloth by evaporation. So, the temperature measured is lower than the dry bulb temperature. So, that is here mentioned as a wet bulb temperature. Then the difference between the two temperature is used to find the relative humidity on the psychrometric chart. For example, if I fix my dry bulb temperature as 55 and my wet bulb temperature as 35. So, the 35 line is here, right, and my dry bulb temperature of 55 degree line is here. So, if you keep this, so this is nothing but a, from this I can calculate relative humidity. How? So, this is 30% relative humidity line and this is 20% relative humidity line. So, what we have seen is dry bulb 55 and wet bulb 35, right. So, wet bulb 35 and dry bulb 55. So, I put this as a 0.1 here. Okay. So, this is a 20% relative humidity line, this is 30% relative humidity line. So, if you go from here it is around maybe I can say the 28%. Okay. So, from dry bulb and wet bulb I can fix the or I can get to know the relative humidity. Okay. The dew point is the temperature at which air becomes saturated with moisture, right. The dew point is the temperature at which the air becomes saturated with the moisture, that means 100% relative humidity, and any further cooling from this point results in condensation of the water from the air. So, we have seen here the air water vapor system, right. So, once the dew point is reached, right. So, there it is a 100% relative humidity. After that, in water vapor won't stay with the air as a water vapor, then it starts condensing as a water. And adiabatic cooling lines are the parallel straight lines sloping across the chart, which shows how absolute humidity decreases as the air temperature increases. So, for example, we have taken here example as a dry bulb temperature of 55 and wet bulb temperature of 35. So, I got 28% relative humidity. So, for example, if I increase the or decrease the temperature, for example, from 55 to I will go to 45. Okay. So, 45 if you see in the wet bulb temperature, so what you get is this point, right, 0.2. Okay. So, in the 0.2 if you see, so if you come here in the straight line, maybe around this and this, right. So, the 0.2 comes somewhere here and 0.1 comes somewhere here, right. So, if you see the difference, right, the 0.1 is at 55 degree dry bulb temperature and wet bulb temperature of 35, and I am just reducing my dry bulb temperature from 55 to 45. So, that gives me the 0.2. So, if you extend that line, so what you get is between 0.03 and 0.02, right. So, the 0.1 is here and 0.2 is here. So, the difference between them will give me the moisture content. That is what it is told. Absolute humidity decreases, the air temperature increases. So, the 0.2 is lower temperature. So, that is having higher absolute humidity, which is nothing but a moisture content. 0.1 is having higher temperature. So, that gives me lower moisture content. So, that means the 1 minus or 2 minus 1 is nothing but a amount of moisture that is removed when you increase the temperature. Okay. So, that is something basic about the psychrometry. So, we are not going into detail. We told about the dry bulb temperature, wet bulb temperature, by using dry bulb and wet bulb how to get the relative humidity, and this one talks about the moisture content, which is nothing but kg upon kg, and we also have seen the adiabatic cooling lines are the parallel straight lines sloping across the chart, which show how absolute humidity decreases as the air temperature increases. So, I fixed my wet bulb temperature as 35 and I increased the temperature from 45 to 55 by noting it down in the 0.2 and 0.1. So, 0.2 is lower temperature, which gives the higher moisture content, and 55 is the higher temperature, which gives me lower moisture content. So, when you increase the temperature, your moisture content is decreasing. So, that is what it is told here. Adiabatic cooling lines are the parallel straight lines sloping across the chart, which show how absolute humidity decreases as the air temperature increases. So, the next one important thing what we have to know is the drying curve. So, in the drying curve we have three regions, region 1, region 2, region 3. The region 1 we call it as a phase of rising rate. So, this is nothing but where the product is getting warmed or opening pores. So, this is nothing but a phase of rising. So, this normally we do not take into account for the calculation of drying time. The second and third region are very important. The phase of constant rate, where drying rate remains nearly constant as the water is removed, and truly constant rate drying may be observed when slowly drying wet sand or paper, but seldom when drying real foods. So, when drying real foods, this may also be avoided for the calculation, because that is the very shorter time, or it may not be even observed, right. But here the constant rate is nothing but drying rate remains nearly constant as water is removed. The region 3 is phase of falling rate. So, below a certain moisture content, called critical moisture content, which is expressed as a Xc, the drying rate drops sharply as the water is removed. So, the phase of falling rate is drying rate falls with respect to X, which is nothing but a moisture content after the critical moisture content is reached. So, here is your drying curve. So, this phase AB we call it as a constant rise or phase of rising period, rising rate period. So, here the product is getting warmed up, or product is preparing its pores to be opened. So, this is a very short period, we do not normally take into account for drying calculations. So, the C to B is nothing but a constant rate period, and the C to D is nothing but a falling rate period. Okay. So, this is nothing but a Xc. So, normally our final moisture content, right, from initial moisture content is nothing but here Xi. So, final moisture content will be Xf, because the equilibrium moisture content is 1, below which I cannot even remove the water. So, my initial final moisture content lies somewhere here. So, this I will take it as a Tf, drying time. This is the initial starting Di equal to 0. So, this is what the drying curve. So, here it is a moisture content which is nothing but grams of water per grams of dry matter, and N is nothing but a drying rate. So, this is a moisture content, this is drying rate X versus Y, and what is the time required for drying a food from an initial moisture content X1 to a final moisture content X2. So, here we can also tell instead of Xf2 and instead of Xi X1. So, T1 T2. Okay. So, here the phi is nothing but a drying rate, which is nothing but minus dW upon m dt, right. So, the W upon m is nothing but kg of water per kg of dry food material. So, the Wm can be written as a x. So, phi is nothing but minus ddt of x, where x is nothing but W upon m. So, if you do the certain calculations here, minus dW is nothing but a m into dx. I am taking these two and writing. So, minus dW is nothing but minus m dx. So, dt gets cancelled. Then this also can be written as, because if you take these two right. So, that can be written as phi m dt, minus dw is nothing but phi m dt. So, from this I can calculate my t, right. So, phi is nothing but minus dx dt. So, my dt is nothing but minus dx upon phi. So, t is nothing but minus x1 to x2 dx upon phi. So, this is I can do it 0 to t. So, total drying time is nothing but minus x1 to x2 dx upon phi. So, this phi is nothing but a drying rate which is a function of x. X is nothing but a moisture content which is expressed in kg of water per kg of dry matter, right. So, usually I get by experimental or by modeling also we can get phi as a function of x. So, this has to be further substituted in the drying time. So, here it is said that if both x1, x2 are larger than xc, the entire drying period takes place at the constant rate. So, if you see here, so this way your moisture content is reducing, right. So, if my x1, x2 both is larger than xc, so that means my x1, x2 comes here. So, this is nothing but called constant rate period. So, total drying time is in the constant rate period, which is nothing but x1 minus x2 upon phi naught is nothing but initial drying rate. If both x1, x2 are smaller than xc, so that means, so here it lies x1 and x2, so that means it is in the falling rate period, right. So, entire drying period takes place in the falling rate period. So, which is nothing but xc minus xc, xc is critical moisture content, E is nothing but equilibrium moisture content, phi naught is nothing but a initial rate of drying, x2 to x1, x2 x1 is the initial final moisture content, dx upon x minus xe. So, after integration what you get is the final formula is this for drying time. So, xe minus xe divided by phi naught into ln of x1 minus xe divided by x2 minus xe. So, this means E is nothing but equilibrium moisture content, x1 is initial moisture content, x2 is final moisture content, xe is nothing but a critical moisture content. If x1 is larger than xe, x2 is smaller than xe. So, if you see here, so x1 is larger than xe, so that means x1 lies here and x2 is smaller than xc. The drying period consists of both the constant rate as well as falling rate. So, constant rate is this formula and remember x2 is replaced by xc because the xc is the final moisture content in the constant rate period and your falling rate period starts with xc minus xc divided by phi naught into ln of xc minus xc because the initial moisture content here is replaced by the xc, right, minus xc divided by x2 minus xc. So, this is the way we calculate the drying time. So, now we are going to see the process of drying a little bit and we are going to see what are all the different dryers used. So, what happens is, so this is my food material, alright. So, here I am sending a hot air. So, with particular relative humidity and temperature and velocity, right. So, when the air sees the food material, so the process is nothing but a convection. Okay. So, it forms a boundary layer. Boundary layer means the velocity of the, so this is nothing but a convection boundary layer, convection boundary layer where your velocity varies from 0 to the free mainstream velocity. Okay. So, this process is convection. Then what happens? The surface moisture of the food gets evaporated, right. So, this is nothing but a evaporation operation. So, when the heat is applied on the surface of the food and it has to conduct through the food material, right. If it is a solid material, the heat has to conduct. So, this process is nothing but a conduction and my moisture should diffuse from the internal side to surface, right. So, this process is nothing but a diffusion of moisture, diffusion of moisture. this is conduction of heat. So, convection of hot air, evaporation of moisture. So, this is what overall happening in the drying process, right. So, what we need to take care, the drying conditions and how much time I need to dry, right. So, drying time. And the mechanism is convection of hot air, evaporation of moisture, conduction of heat inside the material and diffusion of moisture from inside material to the surface of the food material, right. So, this is where we have seen, and one particular thing here we told about the why we do not take normally constant rate of drying is. So, here if you see, actually whatever the moisture content is there in the food material surface is getting evaporated, right. So, the same rate the moisture also diffuse from the inside material and it should come to surface of the food material, right. If there is any difference between these rates, then the constant rate period may not even appear, right, because here in the constant rate period the slowest step is rate of evaporation. In the falling rate period, the slowest rate controlling step or slowest step is diffusion of moisture from the internal side of the food material to the surface, right. If these two are matched, then the process goes smooth, right. So, but in the food material most of the time the rate at which the moisture evaporates near the surface may not be equivalent to the rate of diffusion of moisture from the internal to surface of the food material, because of which the constant rate period may not even appear in most of the real foods. So, mostly it will be done under the falling rate period. Okay. So, now we are going to see the dryers. So, normally the hot air dryers, this is in general. But here we are also thinking about the conventional hot air dryers, what are all the measures can be taken to improve the process as a energy conservation process. One is insulation of cabinets and ducting, that should be done, and recirculation of exhaust air, right. So, whatever the air going in exhaust, that can be recirculated. So, if that we are doing, then we need to also be careful about the outlet temperature can be tolerated by the product, because the exhaust air temperature should be tolerated by the product. It should also be acceptable for reduction in evaporative capacity. And recovering heat from exhaust air, directly it can be recirculated, or we can use some heat exchanger, and that heat can be used to forewarming the feed material or to heat the incoming air. So, this way we can improve the efficiency of the hot air dryers. And use of direct flame heating of natural gas or low nitrogen oxide burners to reduce the product contamination by the products of combustion, right. So, if we use the direct flame or nitrogen oxide burners, then product contamination can be taken care. And drying in two stages. One example we told is like the surface moisture can be removed using hot air, because the falling rate period, right, if the surface moisture which is happening in the constant rate period, but in the falling rate period if the moisture should be removed, we can use any volumetric heating technique, because in the falling rate period the moisture has to diffuse from the inside material to the surface, right. So, in that case we can use the volumetric heating, maybe microwave heating, so that the drying can be efficient, right. So, that is what it is told, the drying in two stages. One is by using the hot air or volumetric heating in the falling rate period and hot air in the constant rate period, and also it is based on the heating medium used and the amount of moisture removal. For example, in the bin drying you will be able to remove only 3 to 6% of the moisture. If the moisture if the high amount of moisture content to be removed, so we can first put fluidized bed dryers, then we can send the dried product from the fluidized bed dryer to the bin dryer to remove the final moisture content. Okay, and also other combination would be spray drying followed by fluidized bed drying. So it is based on the amount of moisture removal, and this mechanism, this two stage drying is based on the heating medium. Pre-concentrating liquid foods to the highest solids content possible using multiple effect evaporator. So instead of removing high amount of moisture in the dryer, so it can be removed previously by or pre-concentrating by evaporation and after that drying for final moisture removal, because the energy per unit mass of water removed in evaporators can be several orders magnitude less than the time required for dehydration. And also automatic control of air humidity by computer control, this also improve the energy efficiency of the hot air dryers. Then bin dryers, as I told earlier, so this is nothing but a small storage dryers, right. So it is batch bin dryer is used to force relatively large quantities of air through the shallow grain depth, so that to obtain rapid drying speed. So that means, so it is a bin, so through which the air is, hot air is passed through. Here you have a food material, so your exhaust air goes, so taking the moisture away. Okay. Mostly storage bins, right. So these are storage bins through which the hot air or normal air at particular temperature is circulated. So here the bin dryers are large cylindrical rectangular containers fitted with the mesh base, and hot air passes up through a bed of food at relatively low velocities, example 0.5 meter per second per meter squared of bin area. So very low velocity air is passing through. They have a high capacity and low capital and running cost, because it can be used as a storage vessel as well, are mainly used for finishing to about 3 to 6% moisture content after initial drying in other type of dryers. This is not a main dryer. So after drying it can be used for storage as well as the drying, right, because the air at particular temperature is passed through these food materials. It removes about 3 to 6% of moisture content. To improve the operating capacity of initial dryers by removing the food when it is in falling rate period, when moisture removal is most time consuming. So they improve the operating capacity of initial dryers by removing the food when it is in falling rate period, when moisture removal is most time consuming. So we said here it can be a final drying equipment, right. The initial drying is done by any other drying equipment, where we take this, this as I told earlier, this is the moisture removal from the interior of the food material, right. So it is a time consuming process. So instead of doing it in initial dryer, so certain 3 to 6% moisture removal can be done in bin dryer as well. While storing it, we can also remove some of the moisture in the falling rate period, that means inside the food material. Surface moisture can be removed from the initial dryer as well. The deep bed of food permits variations in moisture content to be equalized, act as a store to smooth out fluctuations in the product flow between drying and packaging operations. The deep bed of food permits variations in moisture content to be equalized and acts as a store to smooth out fluctuations in the product flow between drying and packaging operations. So between drying and packaging operation, so the bin dryer is used. So that means if there is any variations in the moisture content, that will be taken care in the bin dryer, because it acts as a intermediate storage as well as drying equipment between the drying and packaging operation. The dryers may be several meters high, and it is therefore important that food sufficiently strong to withstand the compression and thus retain spaces between the pieces to permit the passage of hot air through the bed. So this is as I told earlier, this also can be used as a intermediate storage. So intermediate storage will be large storage area, right. So the height of the bin dryers is very much high, and the food materials are stored in high quantities. So in that case it should withstand the compression, because when you are keeping large amount of food material in the bin dryer, so the food material should withstand the compression. as well as there should be a space between the food material for the air to pass through, otherwise the drying will not be done equally. Okay, so this is about bin dryers, our first dryers what we are discussing today in the food processing industries. The second one is spray dryer. So the bin dryers mostly used for solid food material, but spray dryers are used for drying liquids and some of the slurries. The feed is converted into a fine mist or a spray which is then mixed with the heated air. So here we use a atomizer or maybe pressure nozzle as well. Okay. So it sprays, right, the liquid food particle is sprayed and mixed with the hot air. Very rapid drying takes place, converting the liquid droplets into powder particles. So what you get is fine dried powders. The small size of the particle, the size of the particle used to here is 10 to 200 micrometer. So that is the way the surface area of each particle is increased, because if you have a large food chunk, then your hot air to be passed in the less surface area. But when you reduce the food chunks into small particle size, so that means the 10 to 200 micrometer. So large surface area is available for the hot air to pass through, right. So in that way the drying is very quick, right. Instead of drying a large particle, the small particle, the surface area is increased. So that's why the hot air is available for drying very quickly, right. So also the distance that moisture has to migrate within the particle to the drying surface is also relatively small. So think of a food material from here, this point to this point, the moisture has to migrate. So if I have a very small particle, so this height also reduced, in that way also you will have less drying time, which is about 1 to 20 seconds. So there is also significant evaporative cooling effect, so that the surface temperature of the droplets does not rise much above the wet bulb temperature of the drying air until drying nears the completion. So total drying takes place in the temperature less than the wet bulb temperature of the drying air, because the particles or the droplets does not increase the temperature, right. Due to the evaporative cooling effect, the droplets temperature does not rise, which always remains less than the wet bulb temperature of the drying air. And provided the particles once dry are swiftly removed from the drying chamber, heat damage to the product can be limited. So that is also another advantage of spray dryer. One advantage is due to significant evaporative cooling effect, your droplet temperature does not rise and it always less than the wet bulb temperature of the drying air throughout the drying period. The second advantage is the products are swiftly removed from the drying chamber, so that the heat damage to the product is very limited. So for example, this is your drying chamber. Okay. So here you get the air filtered. Remember, this is the food processing application. So we need to take care about the air quality as well. So then with using fan and heater, your hot air is given to the drying chamber. So from here you have a liquid product tank. So from there your liquid food particle is pumped and it is sent to the food chamber. Here we use atomizer to spray the food particle. So this is mixed with the dry air. So your product is taken, maybe we can use here the rotary valve. So the fine powders goes to the storage and distribution line. Storage and distribution. So here it is a fine powders. Okay. So then the air is further sent to the cyclone separator. because the air also has some of the powdered product. So, exhaust air leaves. So, then fine powder is further fed into the final product, or sometimes what happens, it may also goes back to the, it may also go back to the drying chamber for as a recycled product. So, the next one is rotary drum dryers. So, which consist of a rotating drum 2 to 3 meter in diameter and 15 to 20 meter long. Right. The dryer is slightly inclined towards the outlet. So, it is of something of this kind. This is a hollow cylindrical drum. So, this is the air exhaust. This is feed in. So, you have various provisions here. So, here the one is drive gear, then supporting rollers, the third one is discharge screw conveyor. So, your air enters here. So, here we have a heating element which heats the air, and your solid is coming from the inlet in this way. Solid, it is a counter current flow. Okay. So, that is the way the solids gets dried. So, this slanting will helps for easy handling of solids from the inlet to outlet. So, here you will get dried solids. So, the drum also have flights used for lifting the substance when the drum is rotating. So, this here you have a flights, so which helps in right. So, this is in the wheel. So, this is a side view. So, these flights are used for lifting the substances, and the air temperature usually 120 to 175, and velocity ranges from 2000 to 25,000 kg per meter squared hour. So, this is nothing but mass velocity. Okay. So, this is about the rotary drum dryers. So, the next one is fluidized bed dryer. So, normally fluidized bed dryer will have a so, this is your air in, that means hot air. So, you have a perforated plates in which your food particles were kept. Okay. So, this is your exhaust. So, this is attached to the cyclone separator. So, from which your exhaust air is coming out. So, your dried solids you will collect here. So, what happens is here if you draw a graph between velocity versus del P. So, this is a linear line. So, once it reaches the minimum fluidization velocity, minimum fluidization velocity. So, this solid particle starts fluidizing along with the air. So, this is the second condition. When your minimum fluidization velocity of the particle is reached, then it starts fluidizing along with the flowing air current. So, then it goes to cyclone separator where your air and dried solids were separated. That is the way you get the dried solids. So, here you will find some dip in the pressure drop due to fluidization of the food material. So, then it forms the linear line, right. So, and one more thing is also here you need to take care is, for example, here the drying wet granular solids which do not tend to stick or agglomerate. The thing you need to take care is it has to be used for a wet granular solids which do not stick or agglomerate. So, that kind of food solids only you can use this fluidized bed dryer, and incipient fluidization is the point at which the fluidization starts. At this stage the solids are loosened and they will not contact each other. So, they gets loosened and starts fluidizing along with the air stream. At this stage where minimum fluidization velocity is surpassed, the pressure drop slightly falls because it starts fluidizing, and the residence time of the material in the dryer is 30 to 120 seconds for removing surface moisture, that means in constant rate period, and 15 to 30 minutes for removing moisture from internal diffusion, that is for falling rate period. So, this is the mechanism with which your fluidized bed dryer is working. And the next one is tray dryers. So, these consist of an insulated cabinet fitted with shallow mesh or perforated trays, each of which contains a thin layer of food. So, which is about 2 to 6 centimeter deep, right. So, one cabinet is there in which lot of trays, perforated trays, in which the food material is kept. So, the thickness of the food material here is 2 to 6 centimeter. Hot air is blown with the velocity of 0.5 to 5 meter per second through a system of ducts and baffles to promote uniform air distribution over and or through each tray. So, baffles will take care of the uniformity in the heating. Additional heaters may be placed above or alongside of the trays to increase the rate of drying. Okay. So, in the tray dryers you will have a cabinet. So, this is your door. So, you have a trays over here. Okay. So, here is where your food material is kept, which is of 2 to 6 centimeter deep. So, here you have a air inlet. Okay. So, you have got a fan here. So, from the fan it goes to heater, the heated air pass through each of the tray. So, here your food materials are kept. Okay. So, after passing through, so this air exhaust through this. So, after once the drying operation is over, these trays are taken out with the dried solid. Okay. So, what we wanted to tell here is system of ducts or baffles to promote uniform air distribution over and or through each tray, because here there is no guiding rod. So, if we keep baffles or guiding rods, so it will help the air pass through each tray more economically. Okay. So, the dryers are used for small scale production, which is of 1 to 20 tons per day, or for pilot scale work. So, they have a low capital and maintenance cost and are flexible in operation for different foods, because what I need is one cabinet and some trays and one fan and heater. So, it is the capital cost is very much low and maintenance cost as well, because we can take the tray out and cleaning is also very much easy. And however, they have a relatively poor control and produce more variable product quality as food dries more rapidly on the trays nearest to the heat source. So, this problem is there, right. So, that is where here we told additional heaters may be placed above or alongside of the trays to increase the rate of drying. So, here the mechanism is, here your heater stays, right. So, the air which comes here will be so hot. So, the tray next to the heater will get dried too quickly, and further drying damage the food material, right. And also there may be a mechanism, these kind of heaters can be kept near each tray, and the flow rate of air will take care of the temperature and the drying of the food material. So, that is what here it is said, there is a poor control which produces more variable product quality. The tray which is near to the heat source will get dry fast, and the tray which is away from the heat source will take time to get it dried, and so you will get the variable product quality. At low cost semi-continuous mechanism which overcomes this problem by periodically replacing the lowest tray in the stack has been developed. Actually the semi-continuous mechanism means, so there is a control mechanism which keeps changing the tray, first tray to last, then this one to first, like this, right, at intermediate time, at intermittent time, at intermittent interval. There is a semi-continuous mechanism which keeps changing the tray. So, that way we can optimize the drying time among the trays and get the good product quality. And the next one is belt dryers. So, these are continuous conveyor dryers are up to 20 meter long and 3 meter wide. Food is dried on a mesh belt in beds of 5 to 15 centimeter deep. So, belt dryers have the conveyor belt. Okay. So, this goes like this. So, your product is feed in. So, your dried solids will be out from here. So, here something of this kind, because you need place to air to get in. So, here you have a heater and air comes from the filtered air comes from here. So, this gets heated and here is your food material. So, it passes through the food material and it goes out, exhaust air. So, here you have a guiding rods to guide the air along the exhaust. So, this conveyor belt will be conveying the solids from the inlet to outlet. So, this is simple belt dryer, and there are varieties in each cabinet. There may be a for example, the total cabinet will be there. So, here you have many such belts. Right, the feed in comes from here and goes in the second belt and comes here and goes in the second belt. So, this will be done in many belts, right. So, that kind of design also available. So, this is another belt where solids will be coming, and for the air side, so air will be passed through every belt, right, what you have seen here in the tray dryers, right. So, the same kind of mechanisms, so you can also observe in the belt dryers. So, instead of trays, your products will be conveyed through a belt conveyor. So, that is the difference between tray dryers and belt dryers. So, continuous conveyor dryers are up to 20 meter long and 3 meter wide. Food is dried on a mesh belt in beds 5 to 15 centimeter deep. The airflow is initially directed upwards through the bed of food and then downwards in later stages to prevent dried food from blowing out of the bed. So, that means the air flow, as I said here. So, there would be a guiding rods which takes care of the air flow. So, above and below the drying solids, the food to be dried, and 2 or 3 stage dryers mix and repel the partly dried food into the deeper beds. So, which is of 15 to 25 centimeter and then 250 to 900 centimeter in 3 stage dryers. So, that is what I told here. So, instead of one particular conveyor belt in which the food materials are passing, So, we will have set of 3 stages or 2 stages based on the requirement. So, this improves the uniformity of the drying and saves the floor space, and foods are dried to 10 to 15 percentage moisture content and then finished in bin dryers, right. So, the 10 to 15 percentage moisture content is done in belt conveyors, then the food material is passed to the bin dryer for final moisture removal. So, this equipment has good control over drying conditions and high production rates. It is used for large scale drying of foods, for example 5.5 tons per hour belt dryers. The dryers may have a computer controlled independent drying zones and automatic loading and unloading to reduce the labor cost. Right. In the belt dryer, 2 things we need to see. One is it can be done as a single stage or multiple stage. Multiple stage handles high production rates, moisture content of about 10 to 15 percentage is removed, and the solids are further fed into bin dryers for further moisture removal, and the capacity this belt dryers handles is 5.5 tons per hour. And also the airflow is initially directed upwards through the bed of food upwards and then downwards in later stages to prevent dried food from blowing out of the bed, right. So, it should not move from the conveyor belt, right. So, that mechanism is taken care by the guiding rods. Okay, so here the advantages and limitations of different flow configurations. So, it can be done in co-current, counter current, center exhaust and cross flow type. So, if food as well as air flow is in same parallel or co-current mode, one thing is the low moisture content difficult to achieve as cold moist air passes over the dry food. So, that means, so your food is at high moisture level and your air is here from hot air is passing through, right. So, hot air sees the high moisture content food, right. So, then along with the length the moisture content of the air increases, right. So, low moisture content in the food is difficult to achieve because the cold moist air is in contact with the food material at the later stages of the drying. So, this limitation in parallel or co-current flow is taken care here because the counter current type your high moisture food in the end is seen by the hot air, right. So, here the low final moisture content as hot air passes over dry food, right. So, the dry food sees the hot air. So, that limitation in the co-current flow is taken care in the counter current flow. Otherwise, the advantage of co-current flow is little shrinkage or low bulk density or little damage to food, no risk of spoilage. So, this risk of spoilage in terms of heat, right, because the high moisture content food is seen by the hot air, right. So, in that case the thermal damage can be avoided. So, whatever advantages here in the co-current flow, that is a disadvantage for counter current flow. And center exhaust type is nothing but whatever the exhaust air that is recirculated back to the dryer. So, the combined benefits of parallel as well as counter current dryers, but less than the cross flow dryers, because one will be in the co-current flow, other will be in the counter current flow. So, here more complex and expensive than the single direction air flow. In the cross flow type, the food and air flow is perpendicular to each other. The flexible control of drying conditions by separately controlled heating zones, giving uniform drying and high drying rates in cross flow, and more complex and expensive to buy and operate and maintain, that is limitations. So, here are various type of dryers were given and their mode of operation, whether it is good for solid or liquid food or how much initial moisture content it can handle, and whether that particular dryer is useful for heat sensitive materials, and size of the food particle, whether it should be a small or intermediate or granules or pellets or pieces, and whether it can be mechanically strong or not, drying rate is slow, moderate or fast, and what is the final moisture content, and typical maximum evaporative capacity of each dryer, and their examples of the products, everything given in the one table. So, this is taken from the references what I am going to give you. So, the bin dryer we have seen, cabinet dryer, conveyor and belt dryer we have seen, and rotary drum dryer we have seen, and fluidized bed dryer we have discussed. And after that spray dryer we have discussed, and there are lot of dryers which are used for the food industry. So, I request you to refer the material or reference material given in the lecture for further various dryers applied in the food industry. And this is latest technique used for drying of solids, because if you see whatever the dryers we have discussed, so all are based on hot air dryers, and I also discussed about how to increase the efficiency of the normal hot air dryers, what are all the measures to be taken care. But nowadays microwave or dielectric heating drying is used, and microwave augmented freeze drying is used. That means the microwave is used, electromagnetic sources used to dry the food product, and centrifugal fluidized bed drying. So, there centrifugal forces used, and ball drying, ultrasonic waves are used for drying. So, their applications, advantages and limitations are given. So, you may refer. So, this is the further references and additional resources which I have used in this particular lecture, and also this is limited lecture on various type of dryers used for the food industry. So, I request you to further refer these material to get to know further various types of dryers used in food industry. Thank you.